If you're studying for the Google Cloud Professional Data Engineer exam, this one is for you. As we know, Dataflow can handle both batch and streaming data. That is actually one of its strengths. And if you think about streaming data, you might wonder, well, how do you chunk or group together data elements for analysis when you have a constant stream of them? Windows are how we do this. There are three types of windows in Dataflow: tumbling windows, hopping windows, and session-based windows. With tumbling windows, also known as fixed windows, data is divided into distinct, non-overlapping intervals of time. Each window is a fixed size and does not overlap with other windows. You might have a stream of data that is divided into 30-minute tumbling windows, for example. The first window starts at 12 and ends at 12:30. The second one here starts at 12:30 and ends at 1 o'clock. And the third starts at 1 o'clock and ends at 1:30. Each window has a fixed duration. Windows are non-overlapping, ensuring that data is not repeated across windows, and they are sequential, meaning that windows simply follow one another in a continuous sequence. With hopping windows, also known as sliding windows, each window has a fixed duration, similar to tumbling windows. However, unlike tumbling windows, hopping windows overlap. They hop forward at regular intervals. These intervals are called hops. They create a new window that includes the last fixed duration of data. For example, here's a slight modification of the previous example I gave of tumbling windows. Here, each window is 30 minutes in duration again, but a new window is created every 5 minutes. The first window is created at 12:30 and it contains data from 12 to 12:30. 5 minutes later, though, another window is created of the same duration. It contains data from 12:05 to 12:35, and this continues. You can imagine that this could be useful when you need to calculate a metric frequently, but you want the calculation to include a larger window of time. For example, if you're monitoring the stock market, you might calculate average stock price every minute, but include the last 10 or 20 minutes of data in your calculation. The key here is frequency and overlap. We set the size of the window and how frequently a new window starts, the hop size. So in summary, hopping windows have a fixed duration, they are overlapping, and they have a fixed frequency defined by a hop interval. In Dataflow, we simply define our desired window size and the frequency at which these windows should hop forward. Last, we have session-based windows. Session-based windows, instead of having a fixed duration, are defined instead by a gap of natural inactivity in the data. Therefore, they can actually end up being any duration. Let's say we have a timeline of events or new data objects streaming into Dataflow. At some points, they are streaming in more frequently than others, and the points where they are streaming in less frequently are visible as these gaps. If these gaps in data are longer than the gap duration that we have set for our session-based windows, then the next event will start a new session, a new window. So now let's look at a visualization of what the corresponding windows might be like for this data. Because these gaps are longer than the gap duration that we have set, that means that the last data point is the end of the first window. For example, if I set the gap duration to 5 minutes, that means that even if I get one event every 4 minutes and 59 seconds over and over again, Dataflow will continue to consider that part of the same session. Once there is a gap with no data for 5 minutes, then Dataflow will start a new window. One example of this in the real world that you might be aware of is the definition of a session in Google Analytics. The gap duration in Google Analytics is 30 minutes, meaning that if a user comes to your website, that visit to your website continues until they have no activity for 30 minutes. So to summarize, session-based windows are dynamic, meaning that their length can vary greatly because they are defined by a natural gap in the data and not by a fixed duration. They are user-centric, meaning that they are determined by the events generated by users in your data. They involve natural groupings of the data, and they are defined by a gap duration rather than by a fixed window length.